Alright, my name's William. Let's do some math. This is going to be an example of partial fraction decomposition. I'm going to do partial fraction decomposition to separate x over x squared minus 5x plus 6 into two fractions. The first question that you have to ask is it proper? In this case it is. The top has a degree of 1 and the bottom has a degree of 2, which you can see here is the second degree on the bottom. So we don't have to do anything. If it weren't proper, we'd have to do long division. The second step is to factor the denominator. The denominator in this case, the x squared minus 5x plus 6, will factor so that your new fraction should be x minus 3 and x minus 2. Those two factors are both linear factors. A linear factor would be something that looks like ax plus b. You have a constant here and a constant here. A quadratic factor might look like ax squared plus bx plus c. It would be something like that that can't be factored. But both of our factors here are linear, which makes the problem a little bit easier. So, step 3 is to set that fraction equal to the appropriate terms. And the fact that it's linear factors on the bottom means that we need fairly simple terms. We're going to have x over x minus 3, x minus 2 equal to just an a over the first factor, the x minus 3, plus a b over the second factor, x minus 2. You just take each of these things from the denominator. Each factor gets its own term. And they're not repeated factors, so we don't have to worry about extra terms in this example, which is nice. So this over here is what our final answer is supposed to look like. We just need to figure out what that a and b are actually supposed to be. So the next step, step 4, is to clear the fractions. We do that by multiplying on both sides by the terms in the denominator, this x minus 3 and the x minus 2. So on the left, we're just going to have an x because we have multiplied by x minus 3 and x minus 2. And so that's going to cancel with the x minus 3 and the x minus 2 that were in the denominator. We're just going through and multiplying each term by those two factors. So I will write them here next to this a term so that you can see what's happening. And then also, since we have to do the same thing on both sides to every term in order to keep it equal, multiply it to the b term as well. And so here you're seeing that the x minus 3's cancel over here and the x minus 2's cancel. And for this a term, you have x minus 3's canceling. And in the b term, you have x minus 2's canceling. All of that's going to simplify your equation, so that on the left, you should just have an x, and over here we have x minus 2 times a plus x minus 3 times b. And that's pretty nice. It makes it easier to solve at this point. There are several ways that you could solve it from here. The simplest, the one that I recommend you try first, is to pick clever values for x. You could also do synthetic division if it is more complicated, and you could also just plug in some other values in order to get a system of equations, or you could compare coefficients. I'll go through examples of those in other videos, but this one will work out nicely if we just pick clever values. What do I mean by that? I'm talking about a number that I can plug in to one of these x spots that's going to simplify my equation. Because for the equation to be true, it's supposed to be true for every value of x. So I'm allowed to just plug in something. Looking at the first factor, it will disappear if I plug in a 2 for x right here. So I'm going to try that first. Try x equals 2. So I plug in a 2 everywhere for x. On the left, it's just a 2. Over here, we have 2 minus 2, which is going to be 0. That's why I picked a 2. And then 2 minus 3 is b. So as I simplify this equation, I have 2 equals 0 times a. That goes away. And then this becomes a negative 1 times b. So 2 is negative b, or in other words, b is a negative 2. That was very nice. Being able to pick a clever x value let me immediately solve for b. So let's try it again. Let's try x equals 3, because that's going to solve the other factor up here. It'll make that one go away and let me solve for a. So if I plug in a 3 for x, there's a 3 on the left. I would have 3 minus 2 next to my a, and then a 3 minus 3 next to the b. And again, just like before, this is a 0, so that term goes away. I'm left with a 3 equals 1 in the parentheses times a. So a is very obviously 3 here. There's no more algebra required. Now that I have those two things, I have one more step. I have to write my correct answer. This is something that people sometimes forget, so make sure that you don't stop short of this point, because once you have a and b, you actually need to assemble them. So a is 3, b is a negative 2, I believe, right? Yes. So what we should have is that x over x minus 3 times x plus 2 was actually equal to 3 over x minus 3. Was that the right factor? I've already forgotten what it looks like. Yes, a was over x minus 3, and b was over x minus 2. So that would be a negative 2 over x minus 2. Uh-oh, did I do the wrong problem? No, I just wrote the wrong one here. Whew. Everything's fine, folks. Everything's fine. All right, so this over here is your completed answer. And that has allowed you to separate things. And if that's where you need to stop, you can turn off the video here. I won't go into any more calculus, but it tends to make things easier, especially if you're solving differential equations, to be able to break things up using partial fractions. It helps make integration easier, and it lets you do Laplace transforms if you're in 2280, the introductory linear differentials class. But that is all you need to know for 1050, and most of what you need to know for Calc 2.